Assalamu alaikum warahmatullahi wabarakatuh. My name is ABDIWALI Ahmed Muhammad. Today I'm going to present the video presentation of a voltage uh, project. Our group members, our title of project is Polymeric Insulator of Transmission Line in Pollution Area, HVDC Dry, Wet and Contamination Testing. Our lecturer's name is Dr. Muhammad FAIROUZ bin Muhammad YOUSOF. Our member one is Ahmad Radzi, KHALIS in ISHAK, AE 170091. And my name is Abu, and this member two is ABDIWALI Ahmed Muhammad. Introduction. Insulator must be constructed in the construction of a DC tower system to have a sufficient strength to withstand the weight of conductor bundles and other external load. Electrically, it is necessary to prevent current or any surface going through it, and we need enough information on the design of insulator, the use of protective equipment, format, size, and length, performance of estimates and installation. Our problem statement: insulation hinders the transmission of electric current between electric grid locations with a defined potential. Insulation failure is the most common result of electrical phase breakdown. Most insulators were very efficient in contaminated region or a DC line. However, if the use of traditional insulator dramatically increase, there are also rising network incidences of damage. A number of reasons, including aging, which may be caused by increasing temperature and humidity, chemical degradation, and mechanical damage may be impacting the breakdown of insulator at the site. High tension of 132 kV polymer insulator has been divested to address this difficulty in dry and wet lighting conditions. The efficiency of polymer insulator is essential for dry and wet situation. The polymeric insulator has a reduced weight compared to the other insulator. This failure may decrease travel of large equipment and thereby lessen the risk of tower and transmission line. Our objective of our project. The objective to attain are to observe the features of the ideal insulator for 132 kV high voltage suspension of a headline insulator. Second, to develop a high voltage insulator conceptualization using AutoCAD software. Third, to analyze and simulate by using FEMM software, finite elementary software, the stability of voltage and electrical field distribution of 132 kV insulator in a dry and wet circumference. Scope. Our scope of our project of the research. The scope of the research on insulator material with a 132 kV high voltage. In order to obtain this outcome, material and concept should fulfill a specific condition. Hence, the scope of the research is AutoCAD software is the design of conceptual insulator. Magnetic finite element method software simulation work are carried out. 3D models and simulation to make electric field assessment more precise and realistic. 4. Evaluating the wet and dry environment in a 132 kV high voltage insulator. Then outcomes of the work. In order to prevent the current from the flowing through or across their surface in a dry and wet condition, to have the strength to support the weight of bundles and load in order to accommodate for the user in the best possible performance, and the simulation analyzed for a different situation and simulation method are classified and widely distributed.
The preferred design idea was selected and presented in the preliminary work report. The concept design chosen is summarized as below. The following parameters must be used to construct this insulator, which is iron, fiberglass, polymer, air, polluted air, and also water are the materials that were involved in the discovery of this design. The sheet number is 14. The total insulator length is 1500 mm. The sheet diameter is 215 mm. The sheet spacing is 60 mm. The core diameter is 50 mm. For the type of insulator is polymeric. In this study, we want to test our insulator design with 4 conditions, which is dry with clean air, dry with contaminated air, wet with clean air, and lastly wet with contaminated air. Due to its potential advantages over conventional ceramic and glass insulator, especially superior pollution performance and hydrophobic features compared to the conventional ceramic and glass insulator, polymeric insulator will become more popular in recent years for use in EHV and UHV overhead transmissions line. It is necessary to have at least 2 kinds of material in order for polymer insulators to function properly. First is providing electrical characteristics, and then the other one is responsible for providing mechanical characteristics. For this part is figure 1 show the flowchart of FEA simulation on the prototype. The flowchart depicts the phases of this project and the method utilized to accomplish it. The approach for the project is detailed in order to guarantee the process and all techniques, particularly those used to simulate the insulator, collect reliable data and result. The project will include the development and testing of a 132 kV high voltage insulator polymer suspension in a polluted environment. The project will be accomplished by designing and manufacturing the insulator in FEMM software after establishing and materials and identifying all the insulators needs. We need to choose the electrostatic circumstances from the drop-down menu if we want to use this software to analyze the electric potential and electric field strength. Additionally, we use the 2-dimensional planar in millimeters to construct this insulator in millimeters. Then, using the line and curve tools, we must construct the coordinate and connect all of the point coordinates to insulator design. Following that, run simulation and then colorize the FEMM result using the features in the software. The interface allows you to change the graph color of the icon by selecting the display field and the electrical potential, and then the result is then shown. This is an insulator design which is evaluated for its voltage and power distribution by FEMM software. The insulator is designed to simulate in 4 steps. Figure 2 shows the insulator built in 2D design by FEMM software. representing the dry condition with clean air and dry condition with contaminated air. Figure 3, it shows the insulator built into the design by FEMM software, representing the wet condition with clean air and wet condition with contaminated air. Figure 4 shows the output result of the insulator drawn into the FMM are shown in colored drawing. The output colored diagram for an insulator in dry condition is seen in the illustration above. Figure 5 shows the output result of the insulator drawing into the FMM are shown in colored drawing. The output colored diagram for an insulator in wet condition is seen in the illustration above. The voltage distribution system is uniformly distributed and gradually decreases from end of the high voltage to the end of the low voltage in both dry and wet condition. Following that, wet insulator behave similarly to dry air insulator in both clean and polluted air, progressively decreasing the voltage. Although they perform best in dry circumstances, figure 6 shows the voltage graph in a dry insulator. It exhibits both conditions for dry insulator in clean air and contaminated air. Figure 7 shows voltage graph in a wet insulator. It exhibits both conditions for wet insulator in clean air and contaminated air. As shown in figure 6 and 7, polluted air increases the magnitude of the voltage over the insulator surface as the voltage increases from 0 in both dry and wet condition. This kind of pollution is one of the most frequent causes of the flashover in insulator, which may be fatal. This has led to a reduction in resistance of the insulator surface. Electrical field is centered at the contact point between iron and insulator material for polymeric insulators with clean air or contaminated air, as shown in figure 8 and 9. Figure 8 shows the electrical field graph in a dry insulator. It exhibits both conditions for dry insulator in clean air and contaminated air. Figure 9 shows the voltage graph in a wet insulator. It exhibits both conditions for wet insulator in clean air and the contaminated air. This may be explained by production problems at the connection point of the part. The further the point from the insulator in the radial direction, the dry polymeric insulator with contaminated air decrease electrical field than polymer with clean air. Both vectors start on the side of high voltage and go on the side on the insulator at low voltage. FEMM 4.2 software has been used to determine the concentration of voltage and electric field on a clean and contaminated insulator. The main insulator examined was a polymeric insulator. We designed and analyzed both clean and contaminated surfaces, and it was found that contamination has an influence on the amount of voltage and electric field. The distribution impacts can result in lead to a severe or a worse functionality of the insulator. This result of the study may be important in the development and selection of the insulator.
High voltage testing proposal safety risk assessment. Safety document risk. Safety document filed from 22/21 to the 28/21 for a continuous period experimentation only pre-validation of this document is required because they greater than 1 month when the test is circular assemblage. A safety document risk assessment method statement title of experiment test HVDC dry and wet test prepared by Ahmed Radzi KHALIS bin ISHAK and the purpose of experiment test the polymer insulator durability upon electrical storage. B. Equipment to be used circuit diagram or approximate. HVDC generator, polymer and insulator involved. Control balancing experimental procedure. For dry testing, the insulator will energized with both positive and negative polarity of the applied voltage. Clearance of the conductor other structures must be more than 1.5 times length of insulated wire. Our second distance and DC voltage will applied and raised until flash over occurs. Be process for prior times to get the average breakdown voltage. For wet test, there will be dry test procedure but with the insulator being sprayed continuous. Using the nozzles. Risk assessment must be addressed all hazard identified in hazard checklist. This is the hazard checklist. Hazard possibility consequence, electrician and fire, persons or equipment at risk, person and equipment. Control measurement applied to eliminate and minimize the risk. Proper equipment to be insulated from the ground or other potential and perform the operation or energize the platform. Constant supervision is required to avoid any overheating or spark that can be ignite flammable material. Safety document risk assessment. 4. Risk assessment safety matrix safety security value potential consequence of an incident injury given current level of control. 5. Very high death permanent incapacity, virus spread loss, high majority injury, or severe incapacity, serious loss, 3 moderate injury or illness for 3 days or more absentee, moderate loss, slight, minor injury or illness, immediate, first aid only, slight, negligible, no injury or trifle injury, illness. What is the potential of an incident or injury occurring given the current level controls by almost certain occur quite and not likely occur, almost certain not occur. A voltage testing proposal, code of conduct. In this part, the functionality of the polymer insulator has been tested and observed in a variety of situations, including dry circumstances, contaminated circumstances, and wet circumstances. The average voltage breakdown for contaminated and salt must be determined before observation is carried out. All equipment must be checked before starting the experiment to verify its starting of voltage is able to endure during usage. This is done in order to avoid any heating difficulty that may lead on the fire in a fire danger in the future. The setup must be also to be properly grounded to avoid unnecessary faults. Conclusion from high voltage testing proposal. High voltage testing will be demonstrate the polymer insulator's capacity to tolerate voltage based on incidence of the flash over during in the dry and wet experiment. Working with the high voltage is very hazardous then the extreme current must be used while doing tests. Apart from minimizing excessive expensive expenses, and equipment damage. A safe risk assessment is vital to minimize damage, just like burning, which may cause seriously to others. Thank you. That's all. Assalamu alaikum.